Hello and welcome to Mr. Linford's math course. In today's discussion, we're going to be introducing the topic of solving nonlinear equations. And in particular, we're going to focus right now on solving nonlinear equations using something called the zero product property. In this video, we're going to first introduce what are called quadratic equations. We're going to review this thing called the zero product property, and then we're going to piece it together so that we can use this property to in fact solve quadratic equations for unknown variables. Now first what we're going to need to do is make sure that we can define a quadratic equation. A quadratic equation is an equation, first and foremost. It is an equation of the form a times x squared plus b times x to the first plus c equaling 0. Where a, b, and c are all real numbers and a is not equal to 0. So take a minute and make sure that we're able to understand what this is saying. A quadratic equation is essentially a degree 2 polynomial. You'll notice that when we work with this equation, we have a degree 2 polynomial. This trinomial here is what is being set equal to 0. A, b, and c are all just regular numbers, any number on the number line. But it's important that a is not equal to 0. And you might ask yourself, why is it that a cannot be 0? Well, hopefully you recognize that if we, for example, had the equation 0x squared plus 2x minus 5 equals 0, we could simplify that to 2x minus 5 equals 0, and that's no longer really quadratic, is it? This is what's called a linear equation. So a quadratic equation is one that must be of degree 2. This was something we studied back when we looked at different types of functions and reviewed their graphs. So remember, a quadratic equation is a degree 2 polynomial, and we remember that its graph is that of a parabola. Now, when we go and solve quadratic equations, our goal is to figure out what is the x value. What could x possibly be in the given equation? Well, oftentimes we work through these examples and we get stuck. We can very easily see why our traditional methods of algebraic manipulation don't really work. So we need to have a different technique for going and solving these particular equations. Now, before we get into the zero product property, what I'd like to do is to take a minute to actually attempt to solve a quadratic equation. Here we have a quadratic, or a degree 2 polynomial, set equal to 0. So our goal is to solve for the y variable. We want to figure out what number squared minus 2 times that number minus 35 gets a 0. And as we see with our standard manipulation, we could add the 35 over, but then we get stuck with this y squared and the 2y. Well, what do? Do we add 2y over? Well, then we have the variable on both sides, and that really doesn't do anything for us. We could try to square root both sides, but then I have to deal with the square root of 2y plus 35, and that doesn't really break down. So our standard techniques will not work here. We have to try something else. What I'd like you to do is to pause the video and try to think to yourself, okay, of all the methods that I know for working with polynomials, because that's what we've been doing for the majority of our study of algebra, in high school at least, how do we work with polynomials? What I want you to do is think to yourself, if my standard methods of adding and multiplying things to both sides of an equation don't really work right now, what else could I do to work with this polynomial? Take a minute, pause the video, and see if you can figure out where we want to go from here. Well, hopefully you had some time to think this through. But when I come across polynomials, I have this tendency to always want to factor them. Remember, we did this back when we were working with rational expressions. We broke things down, we factored them, and we said it's much easier working with the factors of a polynomial than a much larger polynomial, right? Well, if my standard methods for solving an equation don't really work, well, the only other thing I know to do with polynomials is to factor them. So I guess I might give that a try. Let me try to break down the y squared minus 2y minus 35. Well, I can use box method for this. And as I construct the box, I'm going to set up the y squared and the negative 35. So what times what got us y squared? That would have been y and y. And then what multiplied to get us negative 35, but adds to get negative 2y? Well, of the factors of negative 35, I'm thinking of negative 7 and positive 5. Because I would have 5y and negative 7y. That would give me the negative 2y that I want, but also multiplied to give me negative 35. So what I've done here is I've factored down the polynomial to be y minus 7 times y plus 5 equaling 0. And we might say to ourselves, okay, how does this help, right? All we did was we rewrote what the polynomial looked like. We put it into its factored form. Well, let's try to see if these factors help us to solve the equation at all. Remember, anytime we dealt with factors, we dealt with one thing multiplied by another thing. These are two separate factors. These are each one individual thing. Think of it like that, right? Whatever I plug in for y, I'm going to have one number and another number right here, okay? For example, let's say I plugged in 2 for y. Let's say y equals 2. Then I would have 2 minus 7 times 2 plus 5. That is negative 5 times 7, which is, well, negative 35, okay? So really, these factors are going to represent numbers ultimately, once we plug stuff in for y. So what I want us to do right now is to really try to think what this means when I have one thing multiplied by another thing. I have what we can consider to be a number times another number equaling 0. Take a minute, pause the video, think about what this is saying. A number times a number gets us 0. We're going to have to use logic here. What does this imply about our problem? Hopefully you're seeing that when I say we are taking a number times a number to get 0, we're thinking, what are the situations where this could occur? When is it possible? And I should write that down. When is it possible to multiply two numbers and get 0? When is that possible? Hopefully you're saying only if one of the numbers is 0. That's a big idea. That's something that we really need to realize about this problem. The only way that we can get a number times another number to be 0 is if one of those numbers is in fact 0 itself. If I said multiply two numbers and they equal 0, well, that means one of the numbers has to be 0, or maybe both of them are. So let's clear some space and let's try to think how we can use this idea to solve the problem. Remember, we have the factor down version of this. So we are going to say y minus 7 times y plus 5 equals 0. And we just said the only way that this could work is if either one of these are 0. Maybe both of them are 0, but most likely not in this situation. So what could y be to make this first value 0? Well, if y minus 7 was 0, then I better plug 7 in for y. And then what about y plus 5? Well, if that term was 0, then I better plug in a negative 5 to get that. These are the two solutions for this problem. There are two numbers that will work here. If you plug y equaling 7 into this problem, you will get a 0. And if you plug negative 5 in for y for this problem, you will also get 0. So we now have two potential solutions. What we've done is we factored down the polynomial. We factored the polynomial. And then we set the factors equal to 0. That was important. It's this logical idea that the only way these two values could equal 0 was if one of them was 0. And that's the only situation in which this will work. So this little process here is what we're going to do whenever we need to solve equations. This idea is what's called the zero product property. Let's jump back a page and let's actually go ahead and define what this property is saying. We're going to start by saying, let A and B be two real numbers. So just pick any two numbers. If A times B equals 0, then either A or B equals 0. Maybe they both do. But this is what the zero product property is. We're saying the only way that you will be able to get 0 when multiplying numbers together is if one of them is 0. So, when we think about solutions to quadratics, we're saying, what are all the potential numbers you could plug in to make this whole statement true? And we need to find all of those possible solutions. So now we're no longer just solving for one answer, we actually have to solve for multiple answers. Let's go ahead and let's try this zero product property out on a couple different polynomials. First up, we have this expression. Is it a quadratic equation? The 3x squared plus the 4x, is that expression a quadratic? Well, hopefully you're saying, yes, in fact it is. Some people might say, well, wait a minute, Linford, wait a minute. I see I have a number times the x squared plus another number times the x, but where's the regular number? Keep in mind it's just 0, okay? Remember, the definition said the thing with the x squared can't be 0, but the other numbers could be if we needed them to. So this is, in fact, a quadratic. What we want to do is attempt to factor the polynomial down. So you have to go back to all of the different techniques that you have for factoring and decide which one would work best. So I'm looking at this, and this is a binomial. And I'm thinking to myself, okay, clearly I don't have the difference of squareds or some are difference of cubes. Instead, I'm looking at this and I'm saying, you know, there's probably a GCF in there. And in fact, the GCF is x. So if I factor an x out, I'm left with 3x plus 4. And that's equal to 0. So here are the two factors, x and 3x plus 4. Those are the two values that are being multiplied together to get me 0. So, what could x be? Well, x could be 0. Maybe this number is a 0 after all. Then it would just cancel everything out. Or maybe this factor is 0. So what would I have to plug in for x? Well, if I solve for it, I get 3x equals negative 4. So x equals negative 4/3. So here are my possibilities. You could plug 0 in for x or negative 4/3. These are the two possible solutions that will make everything cancel out and become a 0. Now let's try the next problem. And first off, hopefully you're seeing, okay, we got to work with this a little bit. We have to actually go through, distribute things, and get them to be solved for. So let's go ahead and let's start distributing everything through and try to solve this, or I should say simplify this equation. So first up, let's distribute the 5a through to get 10a squared minus 15a. And then we're going to distribute the 4 to get 4a and a 4. And that's going to be equal to 9a squared minus 6a. Well, now what we're going to need to do is get everything over onto one side. Because we want to make one polynomial on one side and have it equal 0. So let's go ahead and keep simplifying. I'm going to move the 9a squared over. So if I subtract that from both sides, we're left with an a squared. We also can move the, we could add the 6a over. 6a and the 4a make 10a, but when I subtract that from 15a, I get negative 5a. And then there's still just a 4. And that's going to be equal to 0. Remember, the reason we do this is so we have the zero product property being utilized. The polynomial set equal to 0. So we can go ahead and factor this. The factors are, let's see, the first terms are a and a. And then we have to think what multiplies to give us positive 4, but adds to give us negative 5. That's going to be a negative 1 and a negative 4. Well, what things would make each of these numbers 0? Well, if a was a 1, or if a was a 4, then we would get 0. And you can plug that in and test it right in these original problems. So here we saw that you're going to have to sometimes actually manipulate the equation to get it in the form that we want, where we have the quadratic set equal to 0. Similarly, we're going to have to do that in the next problem as well. We can subtract x squared from both sides, and then you'll notice, oh wait, those are just going to cancel out. You can then subtract the 2x, and then let's subtract the 11 as well. So negative 3x and negative 2x is negative 5x. 1 and negative 11 is negative 10, and that equals 0. Now, is this a quadratic? No, it's not. This is just a standard linear equation. We could treat it, I guess, like a quadratic, and we could try to factor it out. I notice that there's a GCF of negative 5 in here. So we're left with x plus 2 equals 0. And then we can say, okay, well, the only way that this would be 0 is if this term is a 0. The only way we would multiply negative 5 and a number to get 0 is if this thing itself is 0. So let's go ahead and let's figure out when x plus 2 equals 0. Well, that's if x is negative 2. And there's our singular solution. Now, again, this was just a linear practice, but the way we did this was just like we would when we have quadratics, where we're factoring it down and setting each of those factors equal to 0. Hopefully this idea is making sense to you. And hopefully you're noticing that in all of these problems, we keep ending up with two solutions. The reason for that, and we'll have to get to this in another video, but the number of solutions is really determined by the degree of the polynomial. That's something that relates to what's called the fundamental theorem of algebra. And again, I'll cover that a bit later in the video, but expect when you solve quadratics to have two solutions, two potential solutions. And when you solve linear, you expect to have one solution. Now, in this problem, number 4, students tend to look at this and they go, oh gosh, Linford, what are you doing? Come on, we got to multiply all this together and then distribute. And I look at them and I go, why on earth would you want to multiply all this together? And they say, well, we have to simplify it, right? We got to multiply everything together. And that's a natural tendency that students want to do when working with these large polynomial expressions. But it's important for us to always keep in our mind, what are we attempting to do? We're attempting to take an equation, something that's nonlinear, and we're trying to factor it down and set each of the factors equal to 0. Isn't this already factored down? And I love this problem because anytime students go and do all this work, I just look at them and I say, all right, factor it. And they sometimes go to me, well, I don't know how. And I say, wasn't it already factored at the beginning? And then you can see all the jaws drop. So keep in mind, it's important that we really don't just take a problem and just start doing mathematics on it. We want to make sure that we understand what is the process that we're doing and what are the steps that we're doing. And more importantly, why are we doing them? So here, we have everything factored down for us. Now notice that we have 4 values being multiplied together. We have the 15, the x minus 3, the x plus 7, and the 3x minus 5. What is the only way that these will all equal 0? Well, that's if one of these 3 terms is a 0. Okay, 15's already set at 15, so we don't really care about that. So I want to know, when is x minus 3 0? Well, that's when x is equal to 3. And when is x plus 7 equal to 0? Well, that's when x equals a negative 7. And then when is 3x minus 5 equaling 0? Well, that's just when x equals 5/3. So here are the 3 solutions. Again, this problem highlights that you just need to take each of the individual factors and set them equal to 0. Really all it is us really relying on our logic and our understanding of how can we take this structure, the setup where we're multiplying things together equaling 0, and trying to reason out what those unknown quantities can be. Now what I'd like us to do is take a minute to try to practice a couple application problems. So first we have a couple consecutive integer problems. These are okay application problems. I've never really come across these much, but they're fun, they're in the book, and they're rather simple to do. The first problem says, I want you to take 2 consecutive integers whose product is 156. What are those integers? So first off, it's probably important for us to define consecutive integers. So I'm going to say that consecutive integers are integers next to each other. So integers next to each other on the number line. So we need to find 2 numbers next to each other on the number line that get us 156. Now that's a fairly small number. We could probably go and just grab a calculator and start testing. But the real reason of what we're trying to do here is trying to come up with an equation for solving this, or trying to come up with a model for what's going on. So we have 2 integers being multiplied together to get 156. Well, how can I represent these integers? Sometimes students say x and y. But the trouble is, those are 2 separate variables. How am I going to solve for either of those? If I wanted to solve for 2 variables, I need to have at least 2 equations. And this problem doesn't have enough information for 2 equations. So instead, I got to do something else besides x and y. It really should rely on just one variable. Okay. X is the first integer. Well, what's the integer that comes after x? Think on a number line. If this number's x, how do you get to the next number on the number line? You add 1. So if one integer was x, the other integer could be x plus 1. Hey, not bad. Okay, this is starting to make a bit more sense. So if I took these two numbers, multiplied them together, I get 156. All right, that equation kind of setup-wise makes sense, but how do I go about solving this? Well, remember, what you have to do is make this into a quadratic equation that's set equal to 0, not 156. So let's distribute this x through. We get x squared plus x, and let's subtract 156 from both sides. So we have x squared plus x minus 156 is equal to 0. Now what we're going to need to do is factor this polynomial down. You could try the box method, but ultimately what you'd come across is that the factors that multiply to give you negative 156 and add to give you 1 are 13 and negative 12. So x plus 13 could be 0, and x minus 12 could be 0. So what could x be? To make this a 0, x would have to be negative 13. And to make this a 0, x would have to be 12. And there are solutions. We're using this idea of consecutive integers to set the problem up, and then once we have it set up, we know that to solve it, we want to get it into a quadratic equation set equal to 0. Try this idea for the next problem. Notice in this one, I'm asking you to find two consecutive odd integers that multiply to give you 143. So these are two odd numbers that multiply to get 143. Your first task is to figure out how to represent these odd numbers. Use a number line to help you out. And then you're going to need to actually go ahead and solve this. So pause the video, take a minute, and we'll check back in. All right, well, hopefully that was enough time for you. The first task that you had to do was to determine what the way of representing odd numbers would be, odd integers. So let's start by saying we have some random odd number, and we'll call it x. That'll be the first one. How do we get to the next odd number? How do I go from one odd number to another? Well, remember, integers go from odd to even and even to odd. They're always alternating. So if I took a number, an odd number, and I added 1 to it, so if I had an x plus 1, this would be even. And that's not what I want here. Instead, how do I get an odd number? Well, I have to add one more, x plus 2. Pick any odd number. If you add 2 more to it, you get to the next odd number. So here's how we're going to represent these two odd integers, x and x plus 2. We can go ahead and start simplifying this. We'll distribute the x to get x squared plus 2x, and I'll subtract the 143 from both sides, so that way the equation is equal to 0. Now what we have to do is factor down the polynomial. Well, as you go and start listing the factors of negative 143 that add to 2, you'll find that the factors would be a positive 13 and a negative 11. These would give you the values that you want. Now, each of these factors have the possibility of being 0. So, what could you plug in for x to make this one 0? Well, you could plug in a negative 13. And what could you plug in for x to make this term 0? Well, you could just plug in an 11. Again, hopefully you're seeing how these are starting to fit together. This idea that when you have everything being multiplied together and it equals 0, one of those has to be 0, or maybe multiple. So you're trying to figure out under what circumstances does that work. Now let's go ahead and let's try an actual application problem. And this is a very common one to come across in Algebra 2, intermediate and college algebra, as well as in an introductory physics course. We're starting by talking about a model rocket. And what we're doing is we're going to shoot that model rocket vertically upwards with an initial velocity of 288 feet per second. The function given by h of t equaling negative 16t squared plus 288t relates the rocket's height, h of t, to the time, t, in seconds after launch. We need to find what times the rocket is on the ground. Again, let's try to decipher what all is going on here. We are launching a rocket vertically up into the air. And what happens with a model rocket? You fire it up into the air, and does it go forever and ever? No. It goes up and up and up, and then it starts slowing down, and then once it reaches the top, it comes right back down, right? And it crashes on the ground. Sometimes the fancy ones have parachutes to help slow them down, but not in this case. The rocket just shoots up, and then it falls back down. So what are some things we know about the rocket? Well, the rocket started on the ground. We launched it on the ground. It's not like we built some big platform and we launched it, several feet above ground. No, it was just on the ground, on the grass, and we fired it into the air. Now, it went into the air. We didn't tell you how high it went, but we gave you a formula to talk about its height. H of t equaling negative 16t squared plus 288t. This formula tells you the height of the rocket for various times in seconds. So obviously at different times during the flight, the rocket was at different heights. Maybe after a second, maybe after 1 second, it was right here. And maybe after 3 seconds, it was starting to come down. And then maybe after 10 seconds, it was right here. So the idea is, as time changes, so does the height. So what we're going to need to do is use this equation, or I should say this formula, or function, if you will, to determine when the rocket was on the ground. When did the rocket's height become a 0? That's what we're trying to find. When was h of t equal to 0? Because that's what's happening right here. H of t equals 0. So we can take our formula and say, well, if height is negative 16t squared plus 288t, and the height's 0, well, we can just set it equal to 0 and solve for it. This is a quadratic. So let's go ahead and solve it. What we need to do is factor the polynomial down. Well, let's see. I have a negative 16 and a 288. Well, 16 is a factor, and in fact, negative 16 is, and so is t. So there's the GCF, and when we factor that out, we're left with a t minus 18. Here are the factors of the polynomial. So we have this term and this term. So negative 16t could be 0. And what's the only way that negative 16t is 0? That's if t is 0. And that should make sense. At time 0, we're on the ground. We haven't moved. So that shouldn't be too obvious, right? When is the rocket on the ground? Well, when you first start the thing, because you're launching it from the ground. The next part says, okay, what about t minus 18? This could be 0 as well. So when would this term be 0? That's when t is equal to 18. So the rocket is on the ground right at the get-go, at 0 seconds after it's been launched, right away. It's also on the ground after 18 seconds. We figured out that it takes 18 seconds for the rocket to shoot up in the air and to fall back down to the ground. This is essentially when working with a vertical motion problem, you're working with this particular formula or this particular function that relates to you two variables. All that we did was say, okay, h of t is height and t is time. I know that the height is 0 and I have to solve for t, time. So it just became a simple math problem at the end of the day. Hopefully this is making sense to you. We're going to try to work through more of these examples as we progress throughout this unit and future units. But if you have any questions or any comments or things you'd like me to go over, please let me know. My email is klinford, that's KLINFORD, @wccnet.edu. And until next time, take care.